Okay, so this is the setup. We have this vacuum pump. It's pretty good. It goes down to 10 to the minus 3 torr, and it's attached on this this hose right here to a valve, and then into the chamber here. So this is a glass chamber, so we can see what happened inside. It has 2 electrodes. Well, it has more than 2, but there's an electrode here and another one here. They're both hooked up to this little transformer. It's pretty cheap on eBay. They claim it can generate a few hundreds of thousands of volts. These are a fairly small transformer, but turns out they do a pretty decent job. This is all powered by this DC power supply that I'm using. So we can go ahead and see what this is. What's gonna happen? Turn the vacuum pump. Alright, so I apologize in advance for the poor quality of this video, but this is very low light. This glow is oxygen and nitrogen being ionized. This striation right here, and that is me playing with the magnet to show you that it is, in fact, ions right there. Okay, so these striations right there is alternating bands of ionized gas. This is the positive, this is the negative. So there is so much thing happening in here. We have electrons coming out of the negative pole, the cathode, bumping into nitrogen and oxygen atoms, creating ions, being accelerated towards the anode and back towards the cathode, creating these bands of lights. When in the dark area, the electrons and ions being accelerated in one direction or another do not have enough energy to create ionization and loss of electrons to cast off light. So we don't see anything. And then they pick up enough speed and start accelerating again, knocking off electrons off nitrogen and oxygen atoms and recombining to get light. So that's why we have this alternation of light and dark band. Also, we can see this if you look towards this area, you can see a slight greenish glow. This is when the electrons are being slowed down into the glass and making the glass glow in this greenish light. In this area, the Brundtland effect is responsible for liberating X-rays. By the way, that's how X-rays were discovered over 100 years ago. So now we get into a vacuum close to 10 to the minus 3, upper 10 to the minus 4 torr. I don't know if you can hear the high voltage, high pitched noise, so you can hear the sparks arcing to the ground, because electricity has a harder and a harder time to break free and pass through. It is said that the tube is becoming too hard and for cold cathode emission. Now I'm going to place this dosimeter to show you that we do have weak X-rays coming out of the green glowing glass area. Now since this is a low power high voltage, we have low power X-rays, but X-rays nonetheless. Many applications derive from the same principle, including cathode ray tube, neon sign, plasma drive, thermonuclear fusion, particle accelerator, and much more. 34 now, 41, so here we go. So I hope you enjoyed this video, and I'll see you on the next one. Please subscribe and comment, and thanks for watching.